All right, good morning, everybody. Um, we are back and we're continuing our conversation about soil. So, we had an introduction to soil, and today we're going to talk about how soil is formed. And that was introduced a little bit in the last video, but we're going to dive into that and we're going to talk about the formation of soil and soil composition. And in order to do that, I think that it's a process that takes some time, and it's kind of difficult to understand unless we can see it happening in right in front of our eyes. So, what are we going to look at today?
So today we're going to look at the Mount St. Helens eruption in 1980 that we talked about in a previous lesson. So we're going to take a look at that and how soil forms after that eruption and how life returns to Mount St. Helens. So then we're going to go from there. We're going to learn a little bit about the composition of soil.
Awesome. Let's get to it.
All right, so today's objectives are going to be explain the processes that help to form soil, describe the characteristics of soil that are used in soil classification, and to identify the processes that helped create the soil in Pennsylvania and actually in Erie County. Now that we've gone over the objectives for today's lesson, we're going to start talking about how soil is formed. So soil is formed mainly through weathering and erosion. So weathering can be either physical or chemical, which we've talked about a little bit in a previous lesson, but today we're going to go more in depth about that. So physical weathering is when rocks are broken into smaller pieces, either through rock temperature rapidly changing, which will cause rocks to expand and crack and break apart, much like if you did a sugar scrub on your face where you rub it in and it'll break off little pieces of dead skin. It's kind of similar to how it will happen in rocks, where those little pieces will get rubbed off. Or water will get into the rock, and then as it freezes, it will expand and then it'll crack the rock open, much like you'll see in this picture. Or another way rock can be physically weathered is when sand and silt picked up by the wind will be blasted into the rock, which will eventually wear it down, much like sandpaper. Also, roots from plants can grow into rocks, and as they grow and the roots get bigger over time, the roots will actually drive the rocks apart and break them into smaller pieces. So once rocks are in smaller pieces, chemical weathering can occur. So chemical weathering is when chemical reactions occur in the rock. So the more surface area the rock has, the more opportunity for a chemical reaction to occur. So these chemical reactions can change the minerals in the rock, they can break the rock down into even smaller pieces, and overall, these chemical reactions help form the nutrient profile in the soil that we have today.
Incredible ability to regenerate and to see new growth.
As much as the eruption caused a change, so much is still the same. It may never be quite the same, but in a lot of ways it will always be the same too.
There's no way stopping nature. It's going to do what it's going to do, and if it's erupted and come back 3 or 4 times, it's going to continue to do that. We can't screw it up enough that she can't fix it.
You see elk, deer, coyotes, cougar, mountain goats in the high country. Many of the same species that were there before the eruption are coming back. The area is alive with wildflowers in the summertime.
You'll often hear ecologists say, we expected this. It looked like a moonscape. It would take forever.
In the Mount St. Helens case study that we showed you in the beginning of the video, you could see that events such as volcanic eruptions can cause lava to flow and destroy the surrounding area. So actually, we can get soil out of this process. So primary succession is the term for when a catastrophic event such as a lava flow can decimate an area and wipe out all the plant and wildlife in that area. So after this event has ended, new plants and animals can survive and re-sprout, which will eventually lead to rocks being converted into soil over hundreds of years that can support simple plants such as grasses or the fields of wildflowers shown in the video. This process can often take a long time, and we're about 40 years out from the Mount St. Helens explosion, and you can see that most of the wildlife, but not all, has returned. Erosion is the second process in which soil can be formed. So this is when soil materials are transported either over small or larger distances, and this can take 80 to 400 years to create just 1 centimeter of topsoil. So this process is very, very slow. So now that we've talked about how soils are formed, we're going to talk about what makes up soils, or what is the composition of soil. So soils can be made up of sand particles, silt particles, or clay particles. The following video is going to give you a quick and easy way to discover on your own what type of particle makes up the soil found by you.
Scientists use 3 words to describe the different sizes of that mineral content. We call it either sand, silt, or clay. Sand is the biggest grain size, and you can see that easily with your naked eye. The next size class, smaller again, is something called silt, which is small plate-like structures that you can just about see. And the last one, which is the tiny grains of clay, which you can hardly see with your naked eye. Soil texture can influence soil in a number of ways. If a soil is very sandy like this one, it's not very good at holding on to nutrients, yet its ability for water to enter it and pass through it is very good. So drainage is excellent in a sandy soil. If you've got a soil with a lot of clay, its ability to hold on to nutrients is excellent, but it also holds on to a lot of moisture too, which can lead to very damp or even waterlogged conditions. Soil texture test is to try and roll the ball into a spherical shape in the palm of your hands. If you can do that, it tells you that it's not pure sand, and you can go on to the next question, which is whether we can flatten this ball into a ribbon shape. I'm going to use my finger and my thumb to do that. It can take a little bit of work, and I'm going to squeeze the soil until it's approximately 3 millimeters in thickness and quite long as a ribbon shape. If I can do that, my next stage is to start working the soil ribbon over my fingers so that it's supporting its own weight. But at some point, like you can see this one is, it's going to want to break. At that point, you want to take the measurement of that distance. In this case, it's broken after about 3 centimeters. My last step in my texture test is to take a small pinch of soil and to rub it between my fingers. It will either feel very smooth, very gritty, or something in between. This one is a very gritty soil.
Soil texture charts, like the one we're using today, give you a standardized method to categorize a soil based on the proportions of these 3 size classes: sand, silt, and clay. The chart leads you to which texture category you have based on how easy it is to work the soil in your hands. The soil we're testing today is a sandy clay loam. This means the soil mineral content is mostly composed of sand, followed by clay.
Scientists that study soil composition use the following triangle diagram to depict the different types of particles that make up soil in the sample that they conducted. So the red circle around loam means that it is a perfect mixture of sand, clay, and silt. Clay is at the top, sand is on the left-hand corner, and silt is on the right. In the previous lesson, we talked about the 5 factors that affect soil formation. So today we're going to talk a little bit more about how these factors affect the formation of soil. So climate, the temperature of the climate and the moisture in the air can speed or slow the chemical reactions in chemical weathering, and soils will develop faster where it is warmer and there is more moisture in the air, and slower and colder and drier climates. So topography is the shape of land and the direction the land faces, and it affects how much sunlight and how much water will stay in this area. So deeper soil banks will form at the bottom of hills due to gravity, and water will actually move down the hill into this soil bank. So additionally, fauna or plants and animals can root or dig and burrow into the soil, and bacteria can eat particles in the soil that can create rich humus. Additionally, parent material, which is when, much like how humans inherit traits such as eye color from your parents, the soil will inherit traits from the parent rock that forms it. Such as soil from limestone will contain calcium, and soils found at the bottom of lakes like Lake Erie are high in clay. Every soil forms a parent material that is then deposited at the Earth's surface. Small materials will be carried by flooded rivers, moving glaciers, or by wind. This parent material can be changed by chemical and environmental processes such as weathering and erosion. The last factor is time, so all of these factors work together over time. Older soils differ from younger soils because they have more time to develop. As soils age, it may look different from its parent material. Soil is dynamic and ever-changing. The minerals, air, water, organic matter, and organisms that contribute to soil constantly change. Some are added and some are lost. Some will move around inside the soil, which will totally change or transform the soil from its parent. Okay, so yesterday we took a look at the image on the left, which describes the different types of soil found in Pennsylvania. So I'm circling Erie County, which is mostly made up of sandy silt particles that contribute to the soil. Presque Isle is mostly made of sediments and sand, which makes sense because there's a lake right there. And then you can see that the Appalachian Mountains in the eastern part of the state are made up of very different types of soil. So where Lancaster is, which I'm going to circle in blue down here, has very fertile farmland, mainly due to the deep soil banks, as it is on the other side of the Appalachian Mountains. Like we mentioned, gravity will pull down the soil and create a deeper bank with a lot more nutrients on that side of the mountain. So if you take a look at the image on the right, you're probably wondering how we got to have different types of soil. Well, Erie County and the eastern part of the state are actually made from receding glaciers that left behind a ton of different deposits, such as that sand and the silt. So if you look down here, you can see that Lancaster has a different type of lowland, which will contribute to a different type of soil. So the 5 factors that we look at also play a part in this. Like I mentioned, the topography of the Appalachian Mountains contributed to the more fertile soil found in the Lancaster region down in the southeast part of the state. So tomorrow we're going to talk about conservation of soil as we've wrapped up the composition and how soil is formed.